So very good evening members gathered here. Today we are going to start a short course on design of mission elements, pre-introduction about the course, and we are planning for 5 to 6 different course modules in this subject, design of mission elements, in connection to the first introductory course. After today, now we will get in touch with the basic introduction, what is meant by design of mission elements in generalized form. So this course is about to discuss about various types of mission elements and the corresponding dimensions for various mission elements in order to ensure safe and reliable operations within the specified constraints. So based on the selection of material and the technical specifications that are uh, specified for different types of mission components. So depending on these two, the design engineer has to confirm whether the proposed mission component ensures safe and reliable operation within the specified limitations or not. So it is a core area of mechanical engineering that focuses primarily on designing the various building blocks of missions and systems. Let us go much briefer in the next consecutive slides. So what is exactly design of mission elements? So it is the process of designing and selecting the components for a particular mission in order to perform its intended function effectively. Say, for example, shaft, bearings, gears, and fasteners. These are the mission elements that has to be selected for a particular mission to serve its basic function more effectively. What is the scope of design of mission elements? So, on various aspects, including material selection, conceptual design, analysis of various forces, and detailed drawings. So, design of mission elements include the following functional aspects as listed out here. The primary purpose of the subject is to create an efficient mission which is more safe, reliable, and highly economical cost-wise. What are the various key concepts of design of mission elements? The first one, it provides a basic foundation for the various mission structures and its intricate components, say shaft, gears, bearings, fasteners, springs, and couplings. So a detailed study we are going to perform in the next future consecutive presentations after the introduction session in the next meeting onwards. But we are going to focus more on these areas, both theory as well as numerical the illustration problems. We are going to consider these more focused areas on bearings, couplings, and shaft. The next one is stress analysis, understanding what are the various types of loads acting on a machine component, how it influences the stress within the component. So it is one of the most essential important thing for designing a reliable, successful machine part. So material selection, choosing the right material based on the properties like strength, durability, etc. So the commonly usable materials are steel, cast iron, and other alloys. So for which application we have to select the right material that will be decided by the engineer, the design engineer, by studying the properties and basic nature of the material. Analyzing the factor of safety for a component to be designed. So it is a safety margin applied to design calculations in order to account for measuring certain uncertainties in material properties and loading conditions. Next one is standardization. So using various standardized components and practice that can simplify the design by maintaining uniformity in shape and size. So we can able to reduce the design cost by improving more reliability. The next one is design process. You are going to see what are the common design process. So the design of machine elements involving nearly 6 to 7 steps. Let us see in detail. First one is problem definition. So clearly define the goal of the problem and and the primary requirements. Next one is a conceptual design. Perform brainstorming analysis and sketch various design options for the missions in order to bring out the most optimum solution. Then do force analysis. Determine the forces and loads acting on the mission elements. Then material selection. Choose the appropriate material based on the properties and loads that will experience. This is the next step which we have to do after force analysis. Then design of elements. Calculate the dimensions and shapes of various machine elements in order to withstand the stress and loads. So in this subject, we are going to see only these as a major part, calculating the dimensions and the profile shape of the machine elements. And we are going to prove whether the stress is within the safer limit or not, according to the applied load. Then detailed design, creating a detailed design drawing and specification for final manufacturing. The last one is optimization, refining the design for further changes in order to improve the efficiency, reducing the cost in the design error, and enhance the reliability in terms of lifetime usage. So these are the key steps in the design process. The following are some of the examples of machine components. So shaft, gears, bearings, fasteners, coupling and joints. These are some of the mechanical components. So later part of the presentations, we are going to discuss these things more detail in terms of analytical approach. Now I conclude the initial introductory session about the course. So now at the end of the lecture, so we come to a understanding that the basic design principles confirms that the machine elements are not only suitable for performing the intended function, but also it must serve the utmost safety and economic requirements. So accordingly, the engineer has to carefully select the material and he has to prepare the design more accurately. So this is what I am concluding in this session. The next meeting, we will see the remaining segment of the subject, the course module, the design of machine elements. So thank you all. The next meeting will be continued by tomorrow. Thank you.